So welcome. So here's another problem to work with. So again, we are going to analyze this by method of joints. So we have here the truss or the framing system loaded by a 1000 kilonewton force here. So as for this first step, we are going to determine the support reaction. So note here that there is no horizontal force, so therefore horizontal force at G is equal to 0. And do not bother yourself by any equilibrium equation. Just bear in mind that this is a symmetrically loaded frame, so therefore RA and RG would have to share 1000 to carry 1000 kilonewton. So each of those will carry 500 each. So the next step is to choose the joint where the force member is only 2, and obviously that is on joint D. So working with the joint D, we first illustrate its force triangle here so that the vertical component is against the direction of 1000 here. That is true to CD and DE. So it has a 500 each going upwards, where tensile orientation is applied for both CD and DE. We take note of the slope BC and CD are similar, that is inclined at 60 degrees with the horizontal line. So getting the value of CDX here is by writing the function of tangent 60. That is opposite all over adjacent CDX. So CDX is 288.68. By this, we can also obtain the value of CD. We just apply the Pythagorean theorem. Hence, we obtain 577.35 kilonewton for CD. By symmetry, we can also say that DE is... Now, moving on downwards, we have to choose again between C and E what will be the most comfortable or the most convenient for us to solve for the unknowns. So if we look at joint C here, there are 1, 2, 3 members that still needs to be computed. For joint E, there are only CE and EF, so those are unknown, which has a minimum variable at E, that is CE and EF. And obviously, DE and EF are parallel, so we note that one. So if we are going to have a rotated axis at that joint, therefore we can say that CE is equal to 0. So how is that? One of the techniques in method of joints, remember that sometimes we need to rotate axis according to the forces. So if we are going to rotate axis at joint E, coinciding our x-axis to the slope of this member, say we have this axis, therefore CE has no other force to counter it, because DE obviously will just be countered by EF. Say this is X and this is Y, so that this is 577.35 also, contradicting or countering the force coming from DE. So we have already a balanced x-axis, and CDX should have no horizontal force or have no component at x. So therefore, this should be equal to 0. Similarly, at joint C, we apply the same principle of rotated axis. So therefore, we have also 577.35 countering the force of CD. So we can also say that CF is equal to a zero force member. Moving on to joint B, so as we can see, there are 1, 2, 3, 4 members, and for the vertical axis, we have BC and AB, as well as the component of BG here. And we note that there is a 500 here as a component of BCY, which is also equal to 500 here, because similarly they have the same component, because both forces are parallel, just contradicting each other. Now this 500 here is to be countered by BG and AB. So this time we have no choice but to go over with the detailed joint method at B. We have here the X and Y axis at joint B. We have here BC is equal to 577.35, having a horizontal component of 288.68. So where this came from? CDX. So we have component CDX to be equal to 288.68, and CDX is also BCX. That is why we have here a 288.68 following the direction of your BC. So I think we should revise this. So here it is. And a downward component for BC equivalent to 500. So we do not bother to have the angle here because we already know the component of BC. We have here an upward force of 500 and a diagonal BG. So we do not know yet the direction of this BG. So we're going to assume a direction. Say I'm going to assume it to be tensile. And this is inclined with respect to the vertical at 45 degrees according to the geometry. And we also have here BF, in which I have to assume it to be tensile. We now write summation forces X is equal to 0. We have negative 288.68, that is leftwards, like this. Plus rightwards BF, plus the component of BG along X, that is BG sine of 45 degrees. And this is equal to 0. So let this be our equation 1. And then we perform again summation forces along Y is equal to 0. We have going downwards 500 negative plus going upwards 500. So by this 2 alone, your vertical forces is now in equilibrium. So the implication is that BG has no other value. Why? Because BF has nothing to do with the vertical. BG here is the force left for the vertical, in which 500 and 500 is already indicated here. But perhaps you might ask, where is 500 came from? So 500 came from joint A actually, because looking at joint A, there is only 500 vertical here going upwards. So meaning it has no horizontal. It has no horizontal reaction. So knowing that there is no horizontal reaction at A, we involve now A, say this is point O. So we have AO has vertical and horizontal component. If that is so, if we will be having a horizontal component here, what is the implication? It will cause an imbalance if we have a horizontal force here. So therefore, AO must be equal to, again, a zero force member. Hence, we have here a compressive force at AB along A that is equal to 500. This is where 500 here came from. So going back at joint B, we have said that we have already a balanced force by these two forces, the 500 here and the 500 above. The same question you might ask, what is left for this joint is BG and BF. Note that BF has no vertical component, I should say. So therefore, if we have a value for BGY, what is again the implication? It will cause imbalance to our Y. So therefore, BG should have no value. And again, this must be equal to a zero force member. So anyway, if we're going to continue our equation here, if BG is assumed to be going tensile, then it is going downwards according to the arrowhead, and that is negative BG cosine of 45 degrees, and this shall be equal to 0. So this is just cancelled, and BG here is really equal to 0. So if BG is equal to 0, going back to equation 1, this is now cancelled. So what is left is BF and this value, wherein we can say that BF is equal to 266.68, in which, if we can see it in the figure, that is the component of BC. In fact, BC has a component of 288.68. Sorry, let us change this one. That is going towards left. So there will be no other force to counter this than BF, that is 288.68. This time it is going rightwards. So as you can see, 288.68 leftward here as a component of BC is being countered by the BF going rightwards. Hence, we can place it here, equivalent to 288.68. That is a tensile force for BF. So by symmetry, if we go directly at point O, we can say that this is also 0 and 0 here, because all of these forces are parallel. So no force here will cause no imbalance to joint O. So by symmetry, finally, we have here 500. Okay, so if we take a look at our analysis, the horizontal force, or there is no lateral force here to cause any lateral forces. So therefore, this bracing or the inside bracing will have no significant effect on the structure if your loading is just a vertical load. However, if there will be a horizontal external forces here or a lateral force applied to this structure, these members should have a force to carry. So by that, I think you should have a practice to do. So again, stand by for another example. So thank you.